to the Maker Show. Today we're going to cover some sizing of stepper motor drivers and the different packages involved in creating a stepper motor driver. I've done some research on this over the past few weeks, months, years. Back little history, back when I was a kid, stepper motors were the bee's knees, something that I wanted to incorporate into every project I could imagine, but the complexity of driving a stepper motor just always got to me. I've tried to do it in many different ways, and now with Arduinos coming out and them having full stepper motor driver programs built in, you can pretty much just drive a transistor and get almost as good results as some of the chips we're going to go over today. The automation of microstepping and stuff like that, taking it off board, off the processor's mind, basically. It's not having to think, have I microstep this many units and do it and then update multiple drives. It's easier to say, give an off-board chip, yeah, I want you to go 100 steps in this direction, and then leave, basically, and let that chip perform its duties. So instead of having to babysit that motor constantly. So we're going to go over a list right now of different motor driver packages I've found and how they're used. A list of the driver packages I found in my studies. The first one is the Allegro A3967. Now that one can drive a motor up to 0.75 amps, but basically what this is your microstepper driver in order to run bigger H-bridge driver chips. So basically, if you have a dumb chip like an H-bridge driver and you don't want the Arduino or whatever you're driving the motor with to babysit the motor, you'd want to add one of these stepper motor driver chips and use it to drive the H-bridge. Down there with the L298, that's one of your basically your dumb H driver chips. Does not have any built-in capacity to do microstepping or anything like that. Now, the most common one that you'll run into on 3D printers is going to be the Polo A4988. It can drive up to 2 amps. Now you're going to have to really heat sink that up to drive 2 amps, but for a small stepper motor on your 3D printer, that's perfect, and they're super cheap. They're broke out on a board already, kind of a breakout board, and the RipRap printers use these all the time on the printer driver boards. They also can come in Arduino shields, that kind of thing, and they're really a good chip to look at. I have some on my 3D printer itself. Now the STL298, these are built into boards all the time for between $5 and $10. They're going to be a board that you're going to drive with your Arduino. It doesn't do any microstepping or anything like that on its own, but paired in conjunction with the A3967, or just use the Arduino's capacity to driver libraries to run that L298, and you're good to go. You're out the door. And those driver boards, those breakout boards, are very cheap, and that's a pretty good package. The other ones we're going to go over is the Toshiba TB6560 and the TB6600. One will has about 3.5 amps max. The other one is about 5 amps max. So if you're running some big stepper motors, we're going to talk about the advantages and disadvantages of each one of those packages. Okay, this is an excellent comparison between the 6600 and the 6560. Basically, one is going to be a little bit higher amperage package. Looks like the 6600 also has a few more features that the 6560 does not have. It looks like it runs at a little bit higher clock frequency. That could be a good thing when you're running those stepper motors faster. We have the K mode is automatic. That's really good. There's a standby mode with the 5 amp one. Overheating protection looks good on both of them. Undercurrent protection and overcurrent protection, both with the better package, and also an air alert. So that's clearly the better package. I'm almost positive it'd probably be double or triple. I haven't looked into the cost of that chip yet, but I've seen a lot of the driver boards use that TB6560 up to 3.5 amps, which you can run a pretty good NEMA 23 engine motor on. So they're you're gonna be pretty good for power requirements of definitely a CNC router, possibly a CNC mill. I might want to go up to a little bit higher amperage driver if I'm really trying to drive something that's really going to take a lot of power, say a conversion of a knee on a Bridgeport or something that takes a lot of power to turn. So and it looks like the working voltage on the 6600 is 50 volts, and that's great. The more voltage you can dump into your motor, basically the faster it'll run, the more power it'll give you. So you don't want to overdo it, because if you get too high, you're going to blow the motor out. But if you have internal protections and stuff like that built in these chips, and part of the advantage of buying these kind of package of chips is you don't need that separate smart chip, the A3967 running it, because that's basically included. You got a giant H bridge included basically with that chip into one. So you got one package that you basically are able to run that stepper motor and take advantage of micro stepping modes and that kind of thing. So so this is the package that I found. This one's going to be the one I'm going to plan to use with my CNC mill and probably my CNC lathe. This one's more than capable. Can run up a stepper motor up to 3.5 amps. Unless I'm getting into a way bigger machine than I think I'm going to build. I think this driver package will do good. This has the 4 stepper motor drivers. Based on that package, the 3.5 amps can take up to 36 volts. So I'll probably give it as close to that as I can reasonably get to without going over too much. Then it also has the parallel port for the Mach 2 and the KCAM 4 series software. We might try to end up running this on Linux as well, Linux CNC. But until we get it in our hands, I'm not going to comment much more about it. But it does have an option for a fifth axis, which a fifth stepper motor. It says here that can run the motor at high speed. It's great for quick movements, quick feeds and speeds. That's always great when you're dealing with CNC, is to have high speeds. So taking advantage of this Toshiba chip, I think, is really going to do our CNC machines good. Well, that's a great little introduction on the different driver packages we can choose from when we come to driving our stepper motors for our CNC projects. One of the things that kind of turned me off was the high cost of controllers. When you were looking through your catalogs or your eBay trying to build your machines, and there's some good packages out there. SandSmart is a pretty reputable company. I haven't bought anything from them, but I've seen a lot of their boards online. They look like a solid company and low cost. So in my shopping, I've come to the conclusion that I'm definitely giving one of their drivers a chance. For my first machine, my burn table, I most likely might go with a slightly smaller packages, just because burn tables don't take quite as much amperage of the stepper motor. But it seems like you can overbuy a little bit when you're dealing with that. But if you have a 5 amp package, you can run a 1 amp per stepper motor on that. And you're basically going to generate almost no heat, and your package will probably last forever. You can drive everything right at its maximum, 5 volts, but obviously you're going to have failures running within those high thresholds. So, if you really need 5 amps all the time, I'd go with 7.5, something like that. Give yourself a safety factor. This has been The Maker Show. I'm Jeff Krepke, and please rate, comment, subscribe, and we really appreciate all the views we get on this channel.